Today we'll discuss how to create bubble maps and where we can use bubble maps. This will be a short webinar, and we'll discuss a couple of ways on how to create bubble maps, and hope you find it useful. So let's start with the first session here. So this is the agenda for today's webinar. We're just gonna show a couple of slides of the different aspects that involve when we're creating bubble maps. And then we'll have a short demonstration on the different types of bubble maps based on the source. You will see that we can create bubble maps based on different type of sources, whether it's wells, GIS data, or database. And we'll have a short summary, and if there is any question, we can answer at the end, or you can send it through after the session, and then I can answer them directly back to you. So bubble maps. Bubble maps can be used to represent one or more values associated with a specific location on a map. So that's the key thing that we need to remember. Bubble maps are based in point data, whether it's well, a point, or any specific data set. So it needs to have an XY location and needs to be based on a point. So if you have point data, you can create bubble maps with that point data. There are, I guess, two types of bubble maps depending on the values that you use. If you use single values, this will be represented as circles, which may be scaled according to the magnitude of the value at a given point. So basically, the bigger the circle, the bigger the value magnitude for that particular attribute or property that we're displaying. So that's the most simple way of working with bubble maps. And the other way to work with bubble map is when we use multiple values, which may be represented as a single point by a pie chart and may also be scaled according to the magnitude of a given variable. So in this case, when we are talking about multiple values, typically the size of the bubble is constant, which represents the attribute is the size of the pie. So for example, in the graphic that you see, for example, a production data set, gas, oil, and water represented as a pie chart. So instead of looking at the size of the circle here, what it's relevant is the size of the pie of each one of those properties, right? So that's the key difference between single values and multiple values. Single values mostly associated with the size of the circle. Multiple values, when we have pie chart, then it's the information is being transferred or conveyed to the user by the size of that pie, right? So that's the two things to consider there. Why do we create bubble maps? Well, because it's an easy way to impart information at a glance in a graphical format. So again, going back to a production data set, if you want to show production data like gas, oil, or water using pie charts, and it's a quick way to do that. And also it provides information quickly, so you don't have to check different tables or different texts. Just by looking at those pie charts, then you get an idea and a quick way of how that production works in your field, for example. As it says, it is typically used to depict production or fluid properties, but it can be used to show any point data, to be honest. So any point data where you have an X and Y location and some properties that you want to display that information, then you can use bubble map. So that's the only key requirement to create bubble maps. So how to create bubble maps in Petrosys, we'll see in detail when I get to the demonstration. But in essence, it's a very straightforward process. From the mapping window, you go to display, bubble maps, and then you get this chart, this panel, like the one that you see on the right-hand side. So it's basically split into three sections. On the top is where we select the data source. So where the data is being read in order to create the bubble map. On the middle section, we apply filters to the data if we need to. So for example, if we want to display only a particular attribute or a particular branch within that attribute, we will do it in this section. And then the bottom section is where we select the attributes that we want to base the bubble maps and other parameters like for annotation and display of that bubble map. So like the size of the bubble map, the styles, and that sort of things. So in essence, those are the three main components that we need to consider when we create a bubble map: the source, the filtering of that source data, and then the attribute and how that attribute will be displayed in your bubble map. So I'm going to show you in the demo basically three examples. One based in well data, another one based in GIS data, and another example based on database data, right? So let's go to the demo right away. I'm going to minimize the presentation, and I'm going to go into my first example here that I have on the bottom of my screen. So let's suppose that I have this map and I have some well data that I want to use as my basis to create some bubble maps. So I'm going to turn on that well data. So you see those well data, I may increase the size of the well path so you can see it a bit better. So I'm going to increase the size of the well path. And at the same time, I'm going to display some well path segments. In this case, I'm reading some well data from Petrel, and that's one of the advantages of Petrosys, that you can connect to a third-party source and display that directly into your Petrosys map. And I also want to display different well path segments of that well data, and I want to apply the same coloring scheme that I have in my Petrol project. So I have all the Petrol zones, all the zones with the same coloring coming from the Petrol project and a particular line style. So if I want to change it in bulk, I select the bulk option, and let's increase the size to 3 so it's more obvious. I'm gonna click OK. And notice now that I'm seeing my well path for each one of those wells, and the coloring is being read directly from the source. So if I want to also display the tops, let's do it quickly so it makes more sense. So I'm going to display all the well tops. And again, the coloring scheme, I'm going to take it from the formation. So it follows the same scheme. And I click OK. And I see how those tops are being displayed along the well path and the data from the tops with the data that is coming directly from Petrel, and even keeping the same coloring scheme from Petrel. So that's a quick overview of the well path segments, which is not the core of this presentation, but it was always important to demonstrate. So I have that well data, and I want to create some bubble maps based on well data. So I'm going to turn it off for a second, and I'm going to go now to display bubble maps. So you see it here. So as I open it, I see that there are, in the top, there is the data source section, and this is where you have to choose the type of data source that you're going to read it from. So on wells, database, or GIS. So let's focus first on well data. So once I choose wells as my data source, my type of data source, then I need to choose which third party or Petrosys source I'm going to use. So for example, you can read data directly from any of these sources and create bubble maps. So you don't need to import the data into Petrosys. You just read directly from the source and you create those bubble maps based on the data that is coming directly from the source. So in this case, let's start with a well data file, which is a Petrosys a native format for web data. Let's go now. If I wanted to filter the data, I could do it here, and I can apply some formula as well. In this case, let's go straight to add the attributes that I want to base that data from. Notice that you can choose between well-headed data or zone data. For this first example, I want to, for example, create some bubble maps around the final TD of each well, so that data is stored in the well headers. So I'm going to choose my data source as well header. Then I'm going to click the plus icon, and I'm going to look for the relevant parameter, which is the final TD in this case. measure depth. I'm going to click OK. I'm going to select the type of fill that I want to apply to this particular bubble map. Notice that there are solid fill, gradient, a color range. Let's choose a gradient. Could be any of these three options. And let's go to choose the type of annotation. So in this case, I could display the name of the attribute and value, or only each one of them, because it every time will be final TD. There is no need to add the name, so I'm just going to put the value only. And then I have the scaling parameter. So let's start with a linear one just to see how that looks. And these are the bubble maps. So in this case, the different coloring scheme, the gradient is the one that is associated to that final TD, but we could also make it relevant to the size of the bubble. So now that we have an idea of those values, we can change the type of scale to linear. And let's say that our reference value will be something around 2000 meters, and that diameter will be 40. So pretty much I'm saying if there is a value in my data that is 2000, then make it a circle of 40. And from there, build a linear scale, because that's the type of scale type that I have chosen, and make it all the other reference bigger or smaller based on this reference value diameter relationship that I have established here. So if I click apply, and notice that how that looks. So in my map, if there were a value that was 2000 meters, then that circle will have a diameter of 40, and then you have a linear scale based on that one, right? If the variability is small, you can play with other type of scale, like logarithmic, for example, and then that will have an impact on how that map and how those bubble maps look like. So if you want to have an idea of the final TD as a bubble map in your chart to see which ones go deeper and which ones are shallow, that's a quick way of doing it, right? So that's if we want to create bubble maps based on a well-headed data. But let's suppose that I don't want to, I want to use some formation data, and I want to display that formation data. So in this case, let's switch from a well data file, Petrosys, and I'm going to change it to a Petrel well data source. So in this case, because I have launched Petrosys from within Petrel, I'm able to connect to the Petrel project that I have open in the background. And notice I have the same two options, well headers information. In this case, I'm going to go to formations option. Then I need to choose the type of data formation. So I could choose formation top, midpoint, or a thickness. So in this case, I can go with formation top. Then I'm going to choose the formation top. Notice that it's the blue arrow, so I can drag and drop as well from formation top into Petrosys if I wanted to. But in this case, I'm going to choose this particular formation top, and I'm going to go with a constant value, and I'm going to go to segments, and I'm going to click apply, and let's see how that looks. Oh, no segment has been chosen, of course. I need to choose the type of data that I want to display. So let's suppose that I want to display some porosity data in this case. So there's an attribute stored information top, and that's the one that I want to display. Then I will go to the scaling parameters, and let's make it constant with 40, and let's make the solid fill gradient again. Let's click OK, and let's click apply, and notice the type of values that I get, right? So it's obvious that the porosity now is expressed between 0 and 1, and that those values are so between 0.1 or 0.2. So the first thing that I can do here is to increase the number of decimals. So let's change it to 2 to see if we have additional information there. So it makes more sense to have 2 decimals, right? Then let's say that I don't want to have that porosity between 0 and 1. I want to have it in percentage. So I can use this section here in the middle, the formula section. So let's add a formula here. So I'm going to click plus here, and I'm going to call this porosity in percentage. And I define the formula, which will be picking the attribute that we have there, porosity, times 100, right? I click OK, and now I have my formula that has been established, so it's added automatically to the list of attributes. I can remove the original one, and now let's apply some scaling to the size of the circle. So I know that now it's in percentage, so it should be something between 10 and 20%. So let's say that I'm going to choose a scale type of linear. I'm going to choose a reference value of 10%, and that will represent a size of a circle of 40 millimeters. So, and that reference, that relationship will be used to apply the different sizes to all the circles. So if I click apply now here, and I forgot to make it solid, so let's choose in this case a solid fill. So I'm going to choose the same coloring for all of the circles. So instead of a gradient, I choose just a single solid fill, click apply, and that's the porosity that we get there. So notice that we have used a formula to increase that, to change that porosity from 0 to 1 into percentage. And we have used the values that we read there and to build a relationship where we can see how those percentage values change across my map, right? That's another example using well data. So in this case, we're using data directly coming from Petrosys, so you don't need to import that porosity data. So let's close this one, and let's do another ones using Excel spreadsheet. So I go to display, bubble maps. So instead of using the data source as well, I'm going to change it to GIS. I notice that we have different options. We can choose all the type of GIS data that we support in Petrosys to build our bubble maps. So in this case, I'm going to use an Excel spreadsheet. So I point to that Excel spreadsheet, which has been automatically selected because I already was working with this previously. Then we need to define the format of that Excel spreadsheet, and we do it in this section here. So we need to, Petrosys will try to recognize the type of a spreadsheet, which is points, and the column names, and the type of on where the X and Y is located. But quickly, the main thing is to associate where the eastern and northern are located. So in this case, it's easy because we have some columns called X and Y. So I need to match those with the eastern and northern. And once I do that, I click OK. I have a preview of the data. I need to assign the CRS because the CRS is something that is not stored into Excel spreadsheet. So I need to be aware of that CRS. And then we can use this information to build my bubble maps. In this case, I want to see the relationship in thickness of these three zones, T1, T2, and T3. And I can do it at once by creating the type of bubble maps that we call pie chart that we were discussing. So let's click the plus icon and let's add one by one, T1, T2, and T3. And now I need to assign different relationships to each one of them and solid at field. So first I want to make it constant, the size of the circle. I want to make it 40. So in this case, the circle will be the same size, and the information will come in the terms of the size of each one of those pies. So I'm going to apply different colors to each one. So let's to T1, let's put this color here. For T2, let's put this blue here. And for T3, let's make it something, I don't know, something like this. Doesn't really matter, to be honest. And we'll click OK. The last thing that we need to specify is the type of annotation. Because we have more than one variable, then it's useful to have the name and the value. We select it and we click apply, and this is how it looks. So we have a relationship between the three zones, and that relationship is what makes the size of the pies in each one of them. So we can see that the annotation maybe is a bit too big, so I can go back to the annotation, maybe reduce the size to 3, and that looks much better. So I have the thickness of each one of those zones and the name and the value, and that's what it builds my my pie chart based on that particular example. So hopefully that makes sense and see the difference. In this case, the size of the circle is irrelevant. What it matters is each pie associated to a different uh, value attribute within that Excel spreadsheet. So this is the first example where we discuss well and JS data. So let's move to a second example where I want to use other type of GIS data. So this is an example closer to home. So working the Northwest Shelf, I have a lot of well data and I have a lot of porosity petroleum data, permeability data that I want to use to create my bubble map. So, and I want to use some of those well location that we have here. So I'm going to turn off that well location for a second. And again, I'm going to go to display, bubble map. In this case, I have data stored in a file database, which is a format coming from Petrol. So it's called I have to call that file database, which it's sorry, I have lost it for a while. I think it's this one. Okay, let's go first to the shape file, which is this one here. So notice that this shape file, I'm calling this porosity underscore values shape file. So in this shape file, I have some porosity information that if I click in the plus icon, I should see it here. It's in decimal. And I'm going to first choose the linear one to see, sorry, the constant one, so I can have a reference, an idea of those values. And this solid fill, let's make it gradient as well. Let's click apply. So it's way too big. So let's change the size to 4 maybe. Still way too big. So let's keep reducing until it's sensible. So maybe this is a bit better. So you see that now those porosity values are associated to those circles here, which are all of the same size. But now, because I have an idea of those values, I can apply a linear relationship. So I can say that, for example, make those values with 10% of porosity, make it a reference diameter of 1, and something like this. Maybe we can even decrease the size to something like this, and that makes more sense. So in this case, I'm displaying some bubble maps from porosity dataset that it's an attribute is stored in a shape file that I'm using to display here. So that's one way of doing things. And let me quickly turn off the other one that I have for permeability data. So I have it there. So it's basically the same principle. You choose the data source, which is GIS. In this case, it's a file geodatabase. So I point to my file geodatabase. I need to select the feature class for that file database, which is this one, permeability underscore millidarcy. And then you need to select the attribute from that feature class. The attribute in this case is this one, K underscore millidarcy, so permeability. And you select the same principle where you select the size and the scaling parameters. So in this case, permeability is a logarithmic attribute. So I make sure that the scale type is set to logarithmic and set the right relationship for reference value, reference diameter, and we get to this bubble map in this way. So same principle, but now instead of using Excel or shapefile, I'm using a file database. I need to point to my feature class and choose the relationship that I have there. So that's the second example. So we have already discussed how to create bubble maps from wells, how to create bubble maps from GIS data, whether it's Excel, shapefile, or a file database. And now let's look into the last example, which is how to create bubble maps from database, right? So I'm going to move into my last example here. So in this case, I have a map that it have a connection to a DBMap database, which is the Oracle solution, our solution for database based in Oracle, which is called DBMap. So I have connected to that database, and now I'm ready to create supple maps directly from the data from that database. So I'm going to go to Display, select again Bubble Maps. So notice that in this case, I have to choose the data source called database, and then I choose the data source. Notice that we can connect to all of these databases that I have here, OpenWorks, Kingdom, etc. In this case, I'm connecting to the Petrosys DB map. I choose the database, which is the one that I have already connected. Then we can choose a template to display the data. So if I click here in template, notice that these are the public templates that we have available. In this case, I'm using the template for the well failure analysis module. I'm not going to go into detail to explain the well failure analysis, but needless to say that it's a model that we use to display the risk assessment that we have applied in each one of the elements in our well data, right? In this case, in our well failure analysis. So I click OK. I need to choose the parameters if I have to, and I can preview the data. So if I click in preview, I see the data that I'm working with from the database. I need to make sure that when we're working with this type of data, with templates, we need to choose the latitude, the longitude, and the coordinate system. So we need to select it from the table that we have there. We can select some filters and we can do some attributes. So for example, the database is a full database with a lot of data. So we may need to filter some data to only reflect the type of data that we want. So I already have created a few of those. So let me turn off this first one, which is the one. So if you see in the bottom left, I have a series of bubble maps, each one associated to an element of the well failure analysis, and one final one with all the play elements. So if I zoom in, notice that in this case, the size of the circle is irrelevant, but it's the color that is the relevant one. So I'm going to double click so I can see how that looks, and notice that when I click plus, I see different elements, like for example, seal, reservoir, trap, and so on. In this case, we are associated to the trap. As I said, the size of the circle is irrelevant, so because it's a constant, the information comes from the coloring of that circle, of that bubble map. In this case, we're using the color range. So we use some ranges and we apply to a different color, and that's what it illustrates. In this case, the level of risk. We have created a color range based on that, and we apply a different coloring associated to this one. So when we see that on the screen, this is what we see. So basically, green is good, red is bad, and that's we have an idea how the trap is been behaving on those particular point locations. The same goes for other elements. For example, seal. In this case, there is not a problem with the seal in my structure. Reservoir, we see that there might be some issues in some areas, but in general, it's good. And then we see the charge where we see that mostly in the structure we are doing okay. A couple of issues maybe on the surrounding areas. And we have a final map where we have all the play elements. So each quarter represents an element of my risk analysis. So if I double click here, notice because it's a pie chart, it's because I have all of them that I have added. And maybe it's a bit too big, so we can decrease the size of the bubble maps and see how that looks. So we have one quarter for each element of the risk analysis, and we see how that behaves. So R for reservoir, charge, trap, and seal, and we see how that works in well further analysis terms. Obviously, all of the quarters being green will be the ideal, and that introduces a risk as we get far from green or to orange or red and so on. But that's another way of how we can use bubble maps, in this case from database data, in order to apply this into our failure analysis. So those are the three examples that I wanted to discuss. So let's go back to the presentation. So final thoughts, bubble maps, use them when you want to convey some numerical information in a graphical way. They can be created using any point data with a numerical attribute. Data can be stored in any third-party data. So you saw I was bringing data from Petrosys, well data analysis, from Excel, from file database, from database. So there is no need to import the data into Petrosys. And that's all. Thank you for your attention. If there are any questions, we can discuss them now, or you can send it through to our support at petrosys.com.au. And don't forget that we have a client portal where we have a lot of workflows in PDF format or short video format, and that's available for all our users. So go into portal.petrosys.com.au and go into the Learn section for more information.